So in this lecture we are going to discuss the two important properties of the carboxylic acid, that is the physical and chemical properties. And this is KK Mukherjee, the Science with Mukherjee Sir YouTube channel. First, let us understand the physical properties. In physical properties, first let us understand how this carboxylic acid exists in the normal room temperature. Up to first 9 carboxylic acid, that is the carboxylic acid which is having the 9 carbon atoms, up to the 9 carbon atoms, it exists as a liquid and its odor is very unpleasant odor. But higher carboxylic acid, they exist as a wax-like solid, and naturally they do not have the unpleasant odor as the liquid carboxylic acid. So that is the first point, that is the physical state that we have discussed. Physical state. Second point, that is the boiling point. Boiling point of the carboxylic acid is more than the boiling point of the other organic compounds like alcohols, aldehydes, ketones, ethers. And that is due to this fact there is a intermolecular hydrogen bonding. And how the intermolecular hydrogen bonding present in the carboxylic acid, let us understand. This is one carboxylic acid molecule and this is another carboxylic acid molecule. And between these two, there is a hydrogen bonding is formed between the carboxylic acid molecule. This is hydrogen bonding. This is hydrogen bonding. And due to this intensive and strong hydrogen bonding in the carboxylic acid present, it will associate, the molecule are associated very largely around each other, and it is required to higher energy to break those molecules for boiling. So it is having the higher boiling point than the other organic compound due to this, and this hydrogen bond is so strong that it can even present at the vapor stage. In the vapor stage, the carboxylic acid present as a dimers. So you understand the boiling point of the carboxylic acid, it is higher than any other organic compounds. Third point, that is important point, that is the melting point. Melting point of the carboxylic acid having the even number of carbon atoms is higher than the next higher and lower carboxylic acid, because in the even number of carboxylic acid, its structure is symmetric, and due to this symmetric structure, it is well packed in the solid state. And this is due to this packing, this is a very orderly packing and a very arranged packing of these molecules for the even number of carboxylic acid, even number of carbon atom in the carboxylic acid, it is going to exhibit the higher melting point as compared to the odd number. Next higher or next lower carboxylic acid. So melting point of the carboxylic acid behave like this way, as the even number of carbon atoms will have the higher boiling point than the next higher and lower. Fourth point, that is the solubility. Solubility, we observe that first four carboxylic acid is found having well miscible in the water, that is very much soluble in water. But as the carbon atoms in the carboxylic acid goes on increasing, its boiling point, its solubility is going to be decreases. Due to the increase of the carbon atoms and the hydrocarbon parts, it is interaction of the hydrophobic interaction has been increasing, and so there is a lesser solubility as the molecular weight is going to be increases. And this carboxylic acid, basically the aliphatic carboxylic acid, is found to be also soluble in the nonpolar solvent like benzene, alcohol or chloroform. In case of aromatic carboxylic acid, the simplest aromatic carboxylic acid is benzoic acid, and this benzoic acid is found to be insoluble in cold water, but they are soluble in the hot water. Okay, so the four basic point of the physical properties that we have discussed. Now we are going to discuss the chemical properties. The chemical properties, when we are talking about chemical properties of any compound or anything, that we are basically talking about the chemical reaction that is being undergo by those compounds. And in the chemical reaction that we can observe, there is basically the breaking of the old bond and the formation of the new bond occurred. So chemical properties of the carboxylic acid we will discuss on that light. That is the different cleavages or breaking of the bonds of at different chemical reactions that we are going to discuss. This is the carboxylic acid molecule. You can see this is a molecule, one molecule we are talking about. In some reaction you can observe this OH bond has been break. Some reaction you will find that a CO bond has been break. Some reaction, whole of the C carboxylic acid going to take part in that reaction. In the some reaction you can see in the alpha hydrogen that is going to take place. So we will discuss on that light, that is the depends the chemical reactions we will discuss, that will be based on that cleavages of the different bonds of this carboxylic acid. So first we are going to discuss these reactions. First reaction that we are going to discuss the cleavage or breaking of the OH bond. When carboxylic acid is ionizes in H2O, so reaction is this. Carboxylic acid is ionizes in H2O. It is going to produce the carboxylate ion. This is carboxylate ion and the hydronium ion. And this carboxylate ion is stabilized by resonance. And this fundamental resonating structure of this carboxylate ion is like this. This electrons has been displaced here and this will go to there and it will create one of the resonating structure and it will become that this. So what we observe, this due to this resonance of this carboxylic ion, it is going to be stabilized. When it is stabilized, then it will, this reaction, forward reaction is going to be occur, and it will going to produce this H plus ion readily. This means that it has acidic property, higher acidic property. Its acidic property is more than the alcohol or phenol. And acetic acid, that is a simplest acid, having the pKa value is 4.76, and this shows its acid property. So here you can see there is a cleavage of this bond, OH bond, and the reaction that we observe when it react with the active metal like sodium. Sodium is active metal, and when it is react with carboxylic acid, it is going to produce the sodium carboxylate salt, and this is going to produce again the hydrogen gas. This is the valence reaction. So this proves the acid property of the carboxylic acid, and this type of reaction we also see in case of alcohol or in case of phenol also. Again, it will going to react with alkali, and it will going to produce the salt also, salt and water. Third reaction, it is also going to react with the weak base also. Weak base is like sodium, hydrogen carbonate, NaHCO3, NaHCO3, sodium hydrogen carbonate, and it is react and it is going to produce this salt and also the carbon dioxide and H2O. And this reaction is very much important reaction in that sense that for any organic compound which is having the carboxylic group or not, carboxyl group or not, that can be easily be predicted from this reaction. When it is been react with the sodium bicarbonate or carbonates, that it is going to evolve the carbon dioxide gas, and this is going to indicate the carboxyl group in the carboxylic acid. So this is a very, very important reaction. This reaction do not show by the alcohol or phenol. Okay, so next reaction that we are going to discuss, that is where there is a, here you can discuss this is the cleavage of the OH bond, and another reaction that we are going to discuss, that is the cleavage of COH bond. This bond will be breaking, this bond will be broke, and the reaction that we observe, that is number one reaction, that is the formation of acid anhydride. First reaction, this is formation of acid anhydride. Acid anhydride. So in this case, in presence of the P2O5, that is the dehydrating agent, or H2SO4, it is going to produce the acid anhydride. As for example, this is ethanoic acid, and one molecule of ethanoic acid will react with the other molecule of the ethanoic acid. It is going to produce this this acid anhydride, and you can see here this CO bond is broke, and it is going to eliminate the one molecule of H2O, and it is going to produce the ethanoic anhydride. This is ethanoic acid, and it is going to produce the ethanoic anhydride. This is ethanoic anhydride. And in this reaction you can observe there is a cleavage of the CO bond. Next reaction that we observe where this cleavage of the CO bond is occur, that is the esterification. Esterification. In this reaction it is carboxylic acid react with the alcohol in presence of concentrated H2SO4 or HCl gas. It is going to form the esters. As for example, this is acetic acid and plus HOC2H5 ethyl alcohol, and it is going to produce one molecule or H2O has been eliminated, and it is going to minus one molecule of H2O, and it is going to produce the CH3 COO C2H5. This is ethyl acetate. This is the ester, and it is going to produce H2O. So in this reaction also you can easily observe that there is a cleavage of the COH bond. So we observe the chemical reaction where there is a breaking of the OH bond, and this proves the acid property of the alcohol, carboxylic acid, and another that is COH bond, that is CO bond, COH bond. That is, in this case we observe different type of reactions that where this breaking of this bond is occurred, that is in case of formation of acid anhydride or in formation esterification of the carboxylic acid when it react with the alcohol. We are going to discuss another very important reaction, that is the reaction with, that we have already discussed three reactions, and this is the 4 number reactions, that is the reaction with PCl5, PCl3 and SOCl2. Here this reaction resembles the reaction with the alcohol also. In alcohol, OH group has been replaced by the halogens. And the same way here the chlorine has been OH group of the carboxylic acid, that you can observe here the carboxylic acid, that 2 groups is there, one carbonyl group and one is OH group, and this OH group is going to be replaced by the chlorine atom, and it is going to produce the acid chloride. So in this reaction here this OH has been replaced by this chlorine atom, and it is going to produce the acid chloride, and it will POCl3 and HCl. This is the very important reactions. Another reactions, it will react with PCl3 and it is going to produce RCOCl plus H3PO3. So here we want to balance it, these 3 and these 3. Now you see whether it is balanced or not. 3 chlorine atom here and 3 chlorine atom here, 3 and 3 here, and H3, H3, POC. This is mostly balanced. So with the PlCl3 you can also found that the acid chloride has been prepared. Again this reaction with SOCl2. SOCl2 means thionyl chloride. it is going to produce again the acid chloride with SO2 and HCl. The very important thing among these three reactions, this reaction is preferred. Why? Because this SO2 and HCl are volatile in the reaction bath, that you can easily get the purified acid chloride. So this is reaction number 4. Now reaction number 5 we will going to discuss, that is the reaction with ammonia. Reaction with ammonia. Reaction with ammonia, when the carboxylic acid is reacted with ammonia, it is going to produce the ammonium acetate. So this is carboxylic acid and it is going to produce the ammonium acetate. And when this ammonium acetate has been heated, it has been heated and it is going to produce the acetamide. So we are taking this particular acetic acid and this is going to produce the ammonium acetate. This is ammonium acetate, and when is it heated, it is going to produce the acetamide. Here we observe the one molecule of H2O has been eliminated. One molecule of H2O. When we remove the one molecule H2O, it will going to produce the acetamide. Similarly, we can observe in case of benzoic acid, it will produce the benzamide. In case of this reaction is a very important reaction where the phthalic acid. This is when we are talking about, this is the 2 carboxylase group in the aromatic acid. This is the phthalic acid. When this phthalic acid is react with ammonia, it will going to produce the ammonium phthalate. This is ammonium phthalate, and this ammonium phthalate when is heated, again it will going to like this eliminate 2 molecules of H2O and it is going to produce the phthalamide. It is going to produce phthalamide. It is going to produce phthalamide, and when this is strongly heated, then at the time you will find there is the elimination of one molecule of NH3. One molecule of NH3, it is going. This is phthalimide, this is phthalamide, and this is phthalimide. So we discussed the reaction with ammonia and reaction with the PCl5, PCl3 and PCl2. Next we will going to discuss another very important reaction, that is the reduction. We are now going to discuss the reduction. That is the 6th number reaction, reduction of carboxylic acid. When you reduce the carboxylic acid in presence of lithium aluminum hydride of borane, diborane in ether, it will going to produce the primary alcohol, lithium aluminum hydride or diborane B2H6 in ether. ether, it will going to produce the primary alcohol. Another very important reduction reaction where you can observe that carboxylic group has been reduced to CH3 group. So it is going to decay in presence of red phosphorus and HI. It is going to produce this alkane. Okay. 7th number reaction, that is the very important reaction, decarboxylation reaction. Decarboxylation reaction. Decarboxylation. In this case, the carbon dioxide from the carboxylic group has been eliminated. When we heat this carboxylic salt of carboxylic acid with the soda lime, the reaction is this. Reaction is this RCOONA, that is salt, sodium salt of carboxylic acid. When it is heated in presence of soda lime, NaOH and CaO, we will heat it, and their ratio is 3:1. It is going to produce alkane. The alkane which having the carbon atom less than the carbon atom present in this carboxylic group, and it is going to produce NOCO3 and H2. This is called the carboxylation. Decarboxylation. Decarboxylation means that is the elimination of the carbon dioxide. You can see the carbon dioxide is eliminated and it is going to produce this alkane. This is called decarboxylation. Next reaction that is going to reaction is a very important reaction, that is Helmholtz-Zielinski reaction. Helmholtz-Zielinski reaction. In this reaction, what is going to happen? The alpha hydrogen, if the carboxylic acid have the alpha hydrogen, this has been halogenated in presence of small amount of the red phosphorus and the chlorine and bromine. It is going to produce the alpha halogenated compound. So this reaction will not undergo by the formic acid, because formic acid do not have the alpha hydrogen. So small amount of red phosphorus and the halogen, it is going to produce the this alpha halogenated acid, where X is here given by X is chlorine and bromine. This is called Helmholtz-Zielinski reaction, and here we will observe the alpha halogenated carboxylic acid. Halogenated carboxylic acid. Next 9 reaction, that is we are going to discuss metic carboxylic acid. Carboxyl group is deactivating group. It will deactivate the benzene ring. This is going to produce when it is halogenated, or nitrated. In case of H2SO4 and HNO3, it is going to produce the meta derivatives. Meta position. At the meta position, there will be the nitro group. Meta nitro benzoic acid. So this reaction is this aromatic carbon shown by the aromatic carboxylic acid, and here this carboxylic acid do not show the Friedel-Crafts reaction. Why? Because with the Lewis acid that is required in the reagent in the Friedel-Crafts reaction, that is LCl3, that is react with the COOH, and that is why it is not going to produce, so that we will have reactions. So that is all for today's lecture. That is the chemical and physical properties of the carboxylic acid. We have discussed all the related that is in your syllabus, and hope all the points is clear to you. If you like this video, you can share to your friends. Thank you for watching this video. Next, the video we will discuss in another topic. Thank you very much for watching.